Okay, so for part 2 of homework dash 1 or 1-1 here, we're going to pick up with the last 3 questions, so 9, 10, and 11. Again, I'm going to go ahead and start by just writing down the correct answers for these. So the displacement should have been positive 18, and the total distance should have been 20 meters. So that way, if you feel like you've already got those answers, kind of just jump forward in the video a little bit, and I don't have to waste your time. But for those of you who do want to review this, right, to find the displacement, I want to find the net area under the curve because it is a velocity versus time graph, right? And if for a velocity versus time graph, the area would equal velocity times time, which, because velocity is meters per second times seconds, would give us meters. Okay, so my displacement, or my distance, both of those really, will come from the area underneath the curve. The key difference here is the fact that the displacement depends on the sign, right? So you can do this however you want. If you wanted to break these up into linear functions, you could, but when it's a nice linear graph like this, you can also just break it into geometric shapes that are pretty easy to work with. Those were actually fairly straight lines for me. That's pretty impressive. Anyway, that's not really the point. So we've got this triangle here, right? I could find the area, though, enclosed by this triangle. It's just got a base of 2 and a height of 4, right? So the area of that triangle would be 1/2 base times height. So in this case, that would pan out being 4. Because it's above the x-axis, that would be a positive 4. Right? This has a height of 2 and a base of 2. So again, 1/2 base times height means this would have positive 2 meters of displacement. And then if I break this up into a rectangle over here, this is a 6 by 2 rectangle, so positive 12 meters. And then I've got this, it looks like it does cut off here at about 9, so I'm going to go ahead and call that a 9. It means it has a base of 1 and a height of 2, so 1/2, 1 times 2 would be 1, again a positive 1. So far for the displacement I have positive 4, positive 2, positive 12, positive 1, so 6, 18, 19. But then if we're talking displacement, the area underneath the x-axis down here, the area enclosed by this, needs to be considered negative. Right? So once again, we find the area of that triangle, and it would tell me that it's negative 1 meter displacement. Again, that just tells me that I started walking back in the other direction. So originally I was walking out, walking out, walking out. I reached a turning point of about 19 meters and then went 1 meter back in the other direction. So the total displacement then was my positive 19 meters of displacement minus my 1 meter returned in the other direction, and that's where I got the 18 meters from. The total distance, keep in mind for distance, I don't care about the direction, right? The total distance is what this person actually felt like they walked or they ran or whatever. So in this case, the total distance is the 19 plus an additional 1, even though that was back in the other direction, he still went that distance. Okay, so there, again, I'm dropping, basically just dropping the signs, and I'm just adding the magnitudes. So 19 plus 1, and that's where I got the 20. Okay, so definitely have to be very comfortable with interpreting graphs like this. We've obviously seen by now some functions as well, where you have to know how to find the area based on integration and such, but this is a very basic one, hopefully to illustrate the point. So then our next question here, right, brings us to one where they give us a function. So they give us the position of an object. The position function of an object here is given by this, where you just get plug some values in for b and c. What is the average velocity from t equals 0 to t equals 2, and then what is the instantaneous velocity? So again, I'll try and save you some time. For part A, the answer should be negative 2.7 meters per second, and for part B, the answer should be 2.1. The instantaneous velocity at this would be 2.1 meters per second. Okay, so if you got either one of those wrong or just want to review this, obviously you can continue to listen. If not, jump ahead a little bit and you can look at the final answer as well. Okay, but in any case, so I'm going to start by taking my function that they've given me here and just plugging in the values. So I'm just bringing this all together. So they told me b is 2, so I've got 2 times t squared minus 6.7 t. So this is the function that represents my position function. And x and t are in standard units, so meters and seconds. The key here is the difference between the average velocity and the instantaneous velocity. It's a very, very important difference. If I want to find the average velocity, the only equation I should be using is my change in displacement over change in time. Okay, so in other words, what I need to be looking at is what is my displacement at 2 seconds minus what was my displacement at 0 seconds, because that's the time they specified, and then divided by the change in time, which obviously would just be 2 seconds. Well, because the average velocity depends on the actual displacements, I'm just going to plug into the original function here. So all I have to do to find my displacement at 2 seconds, I'm just going to plug 2 in for t and see what I get. So 2.0 times 2 squared minus 6.7 times 2. Plug that into my function, and I end up getting negative 5.4 as my result from that. And then when I plug in 0, obviously 0 is significantly easier because both of those have a 0 in it. So when I plug in 0, both of those quantities just end up being 0. So my final my initial displacement at a time of 0 was 0 as well. So then my average velocity is my final, which was negative 5.4, and because it is displacement, that direction, that negative sign, is very important, so I'm going to leave it in there. And then my initial is 0 over 2, and obviously negative 5.4 over 2 is where I got the negative 2.7 meters per second. Once again, because we're talking velocity, the direction is very important, and this tells me that we were moving in the negative, whichever way they've defined the negative direction. So there was part A. For part B, if you ever want to find the instantaneous, this brings us to the other option. So the average velocity, you always just stick with the displacement over time. The average velocity, you should never actually use the velocity function. For the instantaneous velocity, the first thing you want to do is you want to use the derivative to find your velocity function. So I'm just going to differentiate with respect to t. I'm going to differentiate this equation. So I differentiate that, I pull that out front using the power rule. I get 4.0t to the first, minus, again, bringing the 1 out front and then reducing that to 0. So it'd be minus 6.7, no t anymore because now it's t to the power of 0. And I don't have to worry about any plus or minus c's, that's only when we do integration. So then to find the instantaneous velocity at 2.2 seconds, I simply take my velocity function, which I now have. I plug in 2.2 for t. So I plug in 2.2 for t, and then I will calculate what this ends up being. So when I plug that in, the velocity at 2.2, that's where I got 2.1, and hopefully I calculated that right, but I believe I did. 2.1 meters per second, and it did work up being positive, so I'm leaving it as a positive. Okay, so big difference on this question. The big thing I do need you guys to be very comfortable with is the key difference between the average velocity and the instantaneous velocity. So then for our last question, this is a good question at forcing us to use a system of equations. So this is kind of the introduction to that. Okay, so again, I will write down the correct answer so you can see if you got this right. Okay, so if you said that the total time, or excuse me, the time that she needs to be walking, not the total time, but the time that she needs to be walking, should be 72.8 seconds, then you got this correct. So if you're confident with that answer, you can stop, and congratulations on finishing the first homework. If not, continue to watch. Okay, so the key to this problem is breaking it up into the different stages of motion and then bringing the totals together as well. Okay, so I'm going to start by just identifying everything that I know. Right, so a golfer rides in a cart at an average speed of 3.10 meters per second for 28 seconds. Because it's an average speed, the only equation I'm using for that, again, is my change in displacement over my change in time. And they told me a lot of information. They told me the average velocity, the average speed here, was 3.10 meters per second. I don't know the displacement, but I do know the time. And so that actually gives me an avenue to go ahead and find that displacement. So I'm going to go ahead and calculate, just multiply both sides by 28. And I'm going to find that initial displacement to be about 86.8, I think exactly 86.8 meters. So I've got all three measurements for while she's in the cart, which is very helpful down the road. No pun intended, by the way. But anyway, so now she's walking, right? And now let's start thinking about what information we know while she's walking. Well, it says she gets out and starts walking at an average speed, so again I'm using this equation. So this time I'm just considering the second measurements while she's walking. So I'm just labeling everything with a little subscript of 2, so I know these are the second measurements. I know her velocity while walking is 1.30. I do not, however, know either her second displacement or the second period of time. right? So I don't know either of those measurements, so that's where I get stuck. I'm looking for how long does she have to walk, so I'm looking for T2, but I get stuck because I don't know the measurements. So then the key to this problem is we bring both of these together and I think about the totals, right? Because they told me a little bit more information. They said if her average speed for the entire trip was 1.8. So for the whole trip, her average speed would equal her total distance over the total change in time, right? So I know the average speed was 1.80 meters per second. Then the key is I want to represent the totals in relation to the original distances. So I know the total distance here would be her first displacement plus her second displacement, right? Well, because I calculated her first displacement of 86.8, that leaves me with only one variable there, only x2. Okay, so I've got an expression then that helps me represent that. I can do the same thing with the time on bottom. The total time would be the 28 seconds that she was riding in the cart plus whatever that second time, so t2, whatever that second length of time is here. So if I plug that in on bottom, 28 plus t2, I've got an expression that once again is in terms of x2 and t2, and these are the same x2 and t2 as up here. Okay, so I know I used delta up here and I didn't down here, but they are the same measurements. So at this point, hopefully most of us are comfortable with this fact, right? But at this point here, I have two equations in the same two variables, so I can simply do a system of equations and see what I get. The easiest way to do that would be, because I'm looking for t2, let's go ahead and solve this equation for x2. So if I take this equation here and I just multiply both sides by t2, I would get 1.30 t2, and then I would simply substitute that into x2. So now I get 1.80 equals 86.8 plus 1.30 t2 all over 28 plus t2. And at this point it is a single equation with a single variable. Now yes, we do have two different variables expressed here, but once you multiply both sides by 28 plus t2, distribute the 1.8 to both of those, then get your t2s on the same side. It's a relatively simple algebraic expression to solve. We don't even need to do the quadratic equation for this one. So in any case, I'll leave the algebra to you. If you do have trouble with the algebra, just come find me. But again, just multiply both sides by the denominator, and you should get T2 equals 72.8. The nice thing about these problems are you can double check yourself pretty easily by plugging in T2 and making sure that the entire answer makes sense. Okay, so you can always double check yourself by plugging these variables back in and making sure that the answers are consistent with one another. If they weren't, that tells us maybe we did something wrong. But anyway, that finishes the first homework here, so hopefully you guys didn't have too much trouble. If you did have a lot of trouble, come find me so I can help you out, because the quiz obviously is going to be at least as difficult as this homework, if not maybe slightly trickier. So make sure you are thoroughly understanding all of this.